Um, I'm sure most of you guys remember me from MATH141. So today will be our first SI session for the module. We'll be looking at a few problems covering the area of enclosed regions and also volume, as well as a few, if we have time, a few integration problems. So let's have a look at the first question here. So this first question is giving us three curves. Y is equal to 5x, y is equal to 3 minus x, and y is equal to x over 2. And they are asking us to represent these curves. So if we were to use our axis to represent these curves, let's try to imagine how this would look. Again, this is just a rough, but it pretty much shows you what your curves will look like. So the first curve we have is y is equal to 5x. That means when x is equal to 0, right, y is equal to 0. And when x is equal, we need 2 points to draw the curve. So when x is equal to to 1, y is equal to 5. So we have the origin as the first point, as well as when x is equal to 1, this is equal to 5. So we have that. And we can draw our first curve. Sorry. So first curve would look something like this. So this curve is y is equal to 5x. Now our second curve is y is equal to 3x, which means that when x is equal to 0, y is equal to 0 as well. When x is equal to 1, y is equal to 3, right? So
it's 3x or 3 minus x?
Oh, sorry, 3 minus x. Thank you for that. So 3 minus x. So when x is equal to 0, y is equal to 3. When x is equal to 1, y is equal to 2. So let's represent that. So that point there, as well as this point here, somewhere there. So we have it. Something like that. Right, so this would be the curve of y is equal to 3 minus x. The last curve is y is equal to x over 2. So when x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1 over 2. So 0, 0, and 1 over 2, which is somewhere around here. So our third curve would look something like that. Right, so this is y is equal to x over 2. Now, the question was we have represented the curve. So now we are asked to clearly identify the region enclosed between the curves. So if we were to choose a different color to identify that, this would be the region right here. And as you can see, this region can be divided into two, right? So there's the region where the curve y is equal to 5x is on top of the curve y is equal to x over 2, right? So that's the first region here, if you can see, right? this first region here. And then there's the second region where the curve 3, y is equal to 3 minus x is on top of the curve y is equal to x over 2, right? So when you're looking for the area, the total area, so that would be B. So this is our A. Now let's look at B. So our B is asking us for the total area of that region. So we'll have to estimate the areas of the two separate regions, because we can, like I said, we divided this total area here into two sections. So the area of the first section is going from 0 to the intersection between, right? So the point of intersection between y is equal to 5x and y is equal to 3 minus x. So let's identify that point. So at that point, 5x is equal to 3 minus x. That means that x would be equal to 3 over 6, which is 1 over 2. So that point is from 0 to 1 over 2. And in that section, we said that we have 5x on top of x over 2, right? So that's the formula for the area there. And obviously this is easy to integrate. The integral of 5x is just 5x squared over 2 minus the integral of x over 2, which is x squared over 2 over 2, which is 4. So this is evaluated between 0 and 1 over 2. Right? If you evaluate this, you will have 5 multiplied by 1 over 2, 8, right? Minus 1 over 60. Sorry. And minus, when you substitute x by 0 here, obviously you'll have 0 everywhere, so you can just ignore that. And this should give you 9 over 16. That's for the first area. The second area would be the integral from now. We take up from where the last section stops. So from 1 over 2, all the way to the intersection between this point here. The intersection between the curve 3 is equal to, y is equal to 3 minus x, and y is equal to x over 2, right? So let's find that intersection. X over 2 will be equal to 3 minus x, meaning that x will be equal to 3 divided by 3 over 2, which will be equal to 2. So we are going from half to 2, and we are evaluating it such that we have that 3 minus x is on top, so 3 minus x minus the one that's at the bottom here, which is x over 2 dx, right? So that's the second area. And this is evaluated to be 3x minus x squared over 2, right? Minus x squared over 4. Evaluated between 1 over 2 and 2. This gives us, if you substitute in the higher value, 6 minus 2 minus 1 minus 3 over 2. When you substitute half now, 3 over 2 plus, because remember you're subtracting, it will be minus minus, which becomes plus, half squared over 2, which is 1 over 8, plus 1 over 16. And if you add up all of this, you should get 27 over 16. Meaning the total area now, which is just the first area plus the second area, is 9 over 16 plus 27 over 16, which is just equal to 36 over 16, which you can further simplify to be if you divide by 4, 9 over 4. So double check that's calculation there. Any questions? Any questions at all? Can you guys hear me? Okay. I guess I'll take the silence as a good sign. Right. So let's now look at the second problem, which is asking us to sketch the region enclosed by the curves y is equal to 2 plus the absolute value of x minus 1, and y is equal to negative 1 over 5x plus 7. And we are asked to find its total area. So let's try to find that. First, we'll try to evaluate the first curve here as in a piecewise form, because you know that's a function with an absolute value, so you need to define it piecewise. So you need to look at the case where x is greater than or equal to 1, and the case where x is less than 1. So if x is greater or equal to 1, then the absolute value of x minus 1 is a positive value, right? In that case, you would have 2 plus x minus 1, which is just equal to x plus 1. And that is the case if x is greater or equal to 1. In the case where x is less than 1, then this would be a negative value, meaning that to take that, to find the absolute value of that, you'll just have to take the negative. And that will just end up being 3 minus x. And that is if x is less than 1. So now that we have that, we can go on to draw our region. So let's assume that these are the axes, and we have a significant number here, which is 1, right? And now we can clearly see that with the 2 here. So this first curve, if we're trying to draw this first curve, with this 2 here, the curve is shifted by 2 units in the y-axis, right? So that would be somewhere here. Right, so now you can see that on the left side of 1, right, which is the case where x is less than 1, we have the curve being equal to 3 minus x, right? So in that case, if we're to take a value of x that is less than 1, for example 0, that would be that the function is equal to 3, right? So in that case, 3 is somewhere here. So our curve would look something like that on the left-hand side. On the right-hand side, we have that our curve is equal to x plus 1. And in that case, if we take a value greater than 1, for example, let's take 2, we have that our curve is equal to 3. So basically the same there. So that would mean that our curve on the right hand side is looking like that. So now we have our first curve, which is y is equal to 2 plus the absolute value of x minus 1. So now let's look at our second curve, which is y is equal to negative 1 over 5x plus 7. So what happens if x is equal to 0 in that case? If x is equal to 0, we have that our second curve is equal to 7. So 3, 4, 5, 6, 7. 7 there. And then what happens if, for example, x is equal to 5, 2, 3, 4, 5. If x is equal to 5, we have that our curve is now equal to 6. So 6. Right, so we have 2 points. Now we can draw our second curve, which is something looking like that. Negative 1 over 5, x plus 7. And obviously these two curves, as you can see, will meet up at some point. Right? And now that that's done, we have to evaluate the total area of this enclosed area. So let's just represent this area in red. So this is the area that we are dealing with, and we are asked to find its total value. So to do that, we'll have to, since our function, our first curve is a piecewise function, we have to break this down into two sections, right? We have to look at the section where x is less than 1 and x is greater than 1. So that means we will have two areas again. Let's call this area 1 and this area 2. So our area 1 will be the integral, right, from the point of integration of interception here, which let's just quickly, I think it's even clearer if I just write different equations for the different sides of the piecewise function. So this side would be, this side would be x plus 1. This side would be 3 minus x. So on that side, we're looking for the intersection between 3 minus x and negative 1 over 5x plus 7. So I want you guys to attempt this. Give me the intersection points. What is x equal to? Come on, guys. Please attempt this. Let me know what's the intersection point. Obviously, you know that the intersection point is a negative value.
It's 5 and negative 5.
So negative 5 here. negative 5. And here you have 5, right?
Yes.
Right, so the intersection is 5 as well, somewhere here, right? So this is a sketch, obviously, so it should be 5, right? So now let's evaluate our integral. So this would be the integral from negative 5 to 1, right? 1 of, in this section, you can clearly see that the function that's on top is negative 1 over 5 x plus 7 minus the function that's at the bottom, which is 3, negative 3 plus x dx, and this would give you negative 1 over 10, right, x squared, plus 7x minus 3x plus x squared over 2, evaluated between negative 5 and 1. And this will be equal to if you substitute the top part, you'll have negative 1 over 10 plus 7 minus 3 plus 1 over 2. And then now minus the bottom part, which is negative, it will be minus minus, so plus, or rather, no, it would be still be negative. It would be negative 5 squared, which is 25. So negative 25 over 10, right? Minus 35 plus 15 plus 25 over 2. Right, so let's evaluate that. Let's work with the tens together. So that would be negative 1 over 10 plus 25 over 10, which is 24 over 10. So 24 over 10, right? And then 7 minus 3 is 4. And negative 35 plus 15 is negative 20. So negative 20 is plus. So that would be plus 24. And then you have plus 1 over 2 minus 25 over 2, which will give us minus 24 over 2, which is minus 12, which will just give us 24 over 10 plus 12, which will be 144 over 10. So that is our first area. Our second area now is the integral from 1 to 5. What's on top? The function that's on top is negative 1 over 5 plus 7. So negative 1 over 5x plus 7 minus x minus 1 dx. And this will give you negative 1 over 5 x squared over 2 plus 7x minus x squared over 2 minus x. And this is evaluated between 1 and 5. And this will give you, if you evaluate the top, you have negative 25 over 10 plus 35 minus 25 over 2 minus 5. minus 1 minus 1 over 10 plus 7 minus 1 over 2 minus 1. And this will be equal to, let's once again take the 10s together, negative 25 plus 1, which is negative 24 over 10. 35 minus 5 is 30. Minus 7, that's 23. Minus 1, which is plus 24. Negative 25 plus 1, negative 24 over 2, which is just 12. So we have negative 24 over 10 plus 12, which when we add up to the previous area, I'll just I'll just leave it like that, and then just say that the total area now, right, which is A1 plus A2, as you can see, if you add this to that, you'll just have 24.